In this video, we introduce variance and standard deviation as measures of variability. These statistics focus on how far observations fall from the mean, rather than just identifying the center. They provide a more informative description of spread than the range alone, especially when we want to understand overall variability in the data. To understand variance and standard deviation, we begin with the idea of a deviation from the mean. A deviation measures both the distance and direction of an observation relative to the mean. Formally, a deviation is defined as x minus x bar, where x is the observation and x bar is the sample mean. Positive deviations indicate values above the mean, while negative deviations indicate values below the mean. If deviations tend to be large in magnitude, the data are widely spread out and highly variable. If deviations are mostly small, the data cluster tightly around the mean. Deviations contain all the information we need about variability, but we still need a way to summarize them with a single number. Consider two data sets. Data set 1 has the values 1, 2, 3, 4, and 5. Data set 2 has the values 2, 3, 3, 3, and 4. Both data sets have the same mean, that is x bar equal to 3. Despite sharing the same center, their spreads differ noticeably. For data set 1, the deviations from the mean are found by taking each value and subtracting the mean of 3. The deviation are -2, -1, 0, 1, and 2. These deviations are relatively large, indicating greater variability. For dataset 2, the deviations from the mean are -1, 0, 0, 0, and 1. These deviations are mostly small, showing that the data are tightly clustered around the mean. You might wonder why we don't simply average the deviations. The problem is that positive and negative deviations cancel each other out. In fact, the average deviation from the mean is always 0. This makes the average deviation useless as a measure of spread. To avoid cancellation, we square the deviations. Squaring makes all deviations positive and gives more weight to larger differences from the mean. Averaging these squared deviations leads us to the sample variance. The sample variance is defined as the sum of the squared deviations divided by n minus 1. We divide by n minus 1 rather than n because only n minus 1 deviations provide independent information about variability. Variance measures spread, but its units are squared, which makes interpretation difficult. To return to the original units of the data, we take the square root of the variance. This gives the sample standard deviation. The standard deviation represents the typical distance between observations and the mean. Standard deviation answers a practical question. On average, how far do observations fall from the mean? A larger standard deviation indicates more variability, while a smaller one indicates tighter clustering. Because deviations are squared, the standard deviation is sensitive to outliers. Variance and standard deviation measure variability around the mean. They are built from squared deviations to prevent cancellation. Standard deviation is easier to interpret than variance, and is most useful for roughly symmetric data. Together with measures of center, they provide a complete picture of a distribution.